Hey, what day is your dentist appointment?
Oh, it's January 3 cubed.
What?
January 3 cubed.
You mean January 27th?
Yeah, but it's faster to say 3 cubed.
Okay.
And the same thing goes for other numbers. Like, instead of saying, I ate 147 apricots, I could say, I ate 12 squared plus 3 apricots.
Why not just say, I ate a lot of fruit?
I desire precision. 147 has 8 sillies, while 12 squared plus 3 only has 4 sillies.
And sillies are syllables?
Yeah, syllable is silly, 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 but silly is silly, silly. It makes things faster.
I guess.
But what about the other numbers? What's the fastest way to say 192, or 632, or 1024, or any other number? I wrote some code to solve the problem, so let's take a look at the results. For the numbers 0 to a million, the normal names have an average silliness of 15.1. The minimum is 1 for numbers such as 1, 2, and their concatenation, and the maximum is 22 sillies for 777,777. This is because 7 is the longest digit. It has 2 sillies, while the rest...
We can get rid of the ands, right? That would be faster.
Interesting. You're right. Let me update the code. Alright, after the and sanitizer, the max is now 20, and the average is down to 13.2.
That makes sense. It dropped by almost 2, because most numbers would have 2 ands.
Yeah, but 13 is still a lot. We can drop even lower by using rith.
That's arithmetic?
Yeah, with rith, we don't have to say 72. We can just say 8 times 9.
Or instead of 999,999, we can just say 1 million minus 1.
Exactly. Rith drops the average to 11.1. And it drops the max by a lot, down to 14.
What's the max?
14, I just said.
No, which number has 14 syllables?
Oh, 99 times 2,908 minus 5.
I feel like this one doesn't work.
No, it does work. 99 times 2,908...
No, I get that the math works, but it's not really faster. 8 times 9 is easy, but this would take a while for someone to calculate in their head.
Yeah, you're giving them the gift of less talking and more math.
I don't think everyone would consider that a gift.
Here's a breakdown of the operations. Multiplication is the most common, appearing in 79% of all names. Then comes addition, and then subtraction, and finally division.
Wait, those add up to more than 100%.
They're not exclusive, like this name uses both multiplication and subtraction.
Oh, got it. Okay, so I guess multiplication and addition are the best because they're each just one syllable. Minus is 2 and divided by is 4.
Yeah, but I actually use the term over since it's only bisilly.
Oh, nice.
Multiplication is also the best because you can make a large number using 2 small numbers, and small numbers are usually faster. With addition, you'd need at least 2 medium numbers.
Okay, and with subtraction, you need to start with something large, and then for division, you need extra large.
Exactly. And we can use this idea for even better results. How can we make a large number using just extra small?
Exponents!
Or to be less silly, nths. If we include nths, the average silliness drops down to 10.2, and the max goes down to 13. Like with 1,000,001 plus 9 cubed minus 35 cubed.
What's the breakdown by operation?
Here's the before and after. Nths are at the top.
Interesting. Addition and subtraction got more common, while multiplication and division dropped. But they're all still in the same order.
It's also cool to break down the nths by power.
Huh, weird. It's almost all the third and second power.
Yeah, cubed and squared are monosillies, so they're super fast. Everything else is longer, like to the 5th or to the 7th.
Wait, why the 5th? We're missing the 4th power.
We would never say x to the 4th, because it's faster to just say x squared squared.
That's so confusing.
But it's worth it for the fish.
Fish?
Efficiency.
It's not efficient if I have to ask for clarification.
The same thing goes for other composite powers. Instead of x to the 6th, we can just say x squared cubed. That's why most of these exponents are prime numbers.
Oh, yeah.
And it's also why exponents are the most common. With the word cubed, we're saying the operation and the operand at the same time. In the other cases, we have to say them separately, like x times 3 or x plus 3.
Not with division, though. You could just say x thirds.
Whoa, one silly, that's so fish.
Yeah, and you can say halves, fourths, fifths.
I gotta update the code. Okay, so if we add in ths, then we get
Wait,
an average.
what did you say?
Ths.
Ths.
Yeah, like fourths, fifths, sixths. It's super fish, 0 sillies.
Okay, whatever.
With ths, the average only drops by a tenth, and the max is still 13. So not much of a difference. But looking at the breakdown, division jumps up ahead of subtraction.
Wait, that doesn't make sense. If a third of the numbers move to division, wouldn't the average drop by a third of a syllable?
No, because most of the movements weren't improvements, just ties. Like 75 has 4 sillies, but now we can switch to 30 squared twelfths, since it also has 4 sillies.
What? Why not just stick with 75? That's clearer.
Well, our first priority is to minimize silliness, but I think our second priority should be to maximize silliness. And 30 squared twelfths is certainly sillier.
Yeah, that's fair.
And so now we're ready to answer the question from earlier. What's the shortest name for each number? This is 12 cubed ninths. And then we have 12,008 19ths. And finally, 4 cubed halves squared. But what about all the other numbers?
It would be nice if someone made a website where you can just search for them.
But I already made a website.
I know, I was just trying to help you transition.
Oh, okay, thanks. So yeah, follow the link below and you can search for any integer from 0 to 10 squared cubed. I also put the code on GitHub, so check that out. And of course, thanks to the recent supporters of the channel. All right, so let's just do a random one. 40 squared eighths minus 201.
Wait, there's 319,805.
Oh yeah, that one doesn't have an improvement. But then there's 60 times 5,002 plus 3 cubed. Let's try another. Oh, what is this? 8 million tenths minus 14 times 9 cubed. So it's faster to say 8 million tenths than 800,000. Okay, look at this.
What is it?
10,008 thirds twelfths.
Oh my god. Yeah, that tracks.
That's faster to say than 36ths, I guess.